I am going to give a demo of a pressure vessel. I have to thank Alam Steel, who was kind to give me this sample uh, for the educational purpose. A typical pressure vessel looks like this. Pressure vessel is a vessel which contains internal pressure as well as external pressure. Internal pressure wants to expand the vessel, so there is a possibility of failure, which is explosion. And to external pressure means the pressure is exerted on this vessel, which is normally happens in vacuum tankers. So the hazard and risk is implosion, it can crumble. Now, essentially a pressure vessel will have shell courses. Here we have got two shell courses. This is one surseam welding. I've just cut open this portion to show how inside looks. So, and here you'll find on the top these are manholes and opening for nozzle, where nozzles will come for different purpose, pressure gauge, inlet, outlet, and this is also manhole for going inside the vessel. And there are on the sides also there may be manholes depending on the design. And now we have shown in this demo vessel there are two shell courses. The shell courses are rolled from plate and they will be from circular section. So there are two such circular sections. Normally the circular sections are first welded. Long seam welding is done. Now long seam is critical joint, category A joint, because they are subjected to tension. So these joints, long seam welding is done first. So one shell course will be made. Then another shell course is made. Again this long seam is welded. So that will become two barrels, like two cylindrical section. And when we align them, there is some amount of staggering. These two, long seam do not come close to each other. They are spaced. Now, once these two shell courses have been welded inside and outside as required, they are aligned and the circumferential seam welding is done. Now, the joint preparation could be single V, could be double V, depending on the thickness of the shell courses. Typically, single V for smaller thickness, double V for higher thickness, 20 mm and above. It is more economical to have double V welding. So, welding will be done from inside and outside both. So, outside, once it is done, inside will be gouged, ground, and then welding will be done from inside, that you can see here. Now, once that is done, these two dish ends will be finally coming. Dish ends are also critical because they will be also under tension. So now, once these two shell courses have been joined by a surseam, then the dish ends will be aligned and dish end welding will be done. And then after that, whatever NDT is required, where or RT will be done, UT will be done, MPI, and whatever test is required as per ITP will be done. Now, so this is typically a section looks like. So you have got the dish end and there will be manhole opening nozzles, and these will sit on saddle support. Now, saddle supports are actually given this curvature, one plate, web plate, and the flanges, and then this is welded, and the two saddle support, and there will be pad here so that there is a wider base for the supporting, so that it's not a pointed load. So there will be some saddle support pad where the vessel will come and sit. Then hydro test will be performed. Painting should not be done before hydro test, because in case of any leakage or seepage, which is least expected but can be seen with the exposed welded joints, and once the hydro test is satisfactorily done, then their surface preparation is done, blasting and painting coating is applied on the outside and inside depending on the requirement. Now typically what inspection we do is addition inspection we do. We check the crown radius and knuckle radius, whether the formation is proper, the diameter, and there is no thinning down on this portion, because when they are doing spinning to form these additions, there may be thinning. So we check that there is no thickness below acceptable level, and we check the radius of curvature, crown radius and knuckle radius, and then straight face and the thickness, of course, material of construction. So, and also they are stress relieved, so we check the stress relieving reports. Then in the long seam root, normally penetrant test is performed after these are done, and depending on ITP, and then the welding, once it is done, X-ray is done. Normally these junctions where circumferential and long seam is coming, that is where most problem can happen. So one of the requirement is that the long seam, while welding, they start on a run-on plate and goes on run-off plate, so that there is no defect starting at the edge. So defect will start if there is anything that will be cut off. So some run-on tab or extra plate is given when the shell course is welded, so that the welding starts before this point and ends after this point, and some part is removed. So this joint remains good in quality and without any flaw. And then end preparation will be done, and then circumferential joint is done. So long seam welding will be done first before the search seam. And here again, this will be done at the final stage. Here what we check the circularity, we check the length of the vessel from tangent to tangent, and the diameter and circumferential dimension, and there is no ovality, and of course the saddle support when they're checking, so that the saddle will have the holes, because this will go and sit on the foundation. So we check that there is no problem with those alignments. Otherwise, after the whole thing is welded and the whole vessel goes, it will not sit on the foundation. The whole foundation may have to be broken, and this kind of mistakes also happen. So what is most important is those dimension, so that when it goes, the erection becomes easy. Yeah, this is in brief how pressure vessels are inspected. And of course, we'll check the welder qualification, who did the welding, procedure qualification. When the welding is performed, before that, the welded joint must be qualified. In other words, it is right electrode used, right voltage, right current, right travel speed, and all those will give the right property, so that this weld is strong enough to take the load of the vessel. Sometimes the whole vessel goes for stress relieving, and sometimes localized stress relieving is also done, but many a times the whole vessel is stress relieved, and then it goes for service. But stress relieving is done before hydro test. After hydro test, there is no welding or any work done on this vessel, and then painting and coating, and they are transported in a safe manner, so that they are sitting properly on the trailer. They do not fall. In fact, a lot of incident happens while transportation. Once it happened, one of the vessels that we did inspection in Sharjah, and while transporting, the vessel got dropped while in an accident, and the whole newly constructed vessel was completely damaged and had to be repaired. So this is what is briefly the process of inspection. I hope I could give some understanding briefly, and there will be more detailed discussion on this subject, on the design concept and fundamental concept. What are the standards used for inspection. We follow ASME Section 9 for welding and welder qualification. And for the selection of electrodes, we are using ASME Section 2 Part C. For the material, we are using ASME Section 2 Part A or Part B for non-ferrous, Part A for ferrous, and of course for the design, ASME Section 8 Division 1 or Division 2 as per the requirement of the customer. Once this is done, there'll be a nameplate. There's a requirement, what kind of information, normally maximum allowable working pressure, design temperature, manufacturer, and ASME code license when it is ASME coded vessel. That's going to be marked with the use stamp or appropriate stamp. Now, use stamp is stamping to conformity to certain requirement of ASME. ASME is a code in US which is a legal requirement in USA. When a standard is enforced by law, it is considered a code. So in this part of the world, ASME is considered to be a standard. It's adopted by the client and the countries, but in US, it is a code. It has given a legal status. In India, there are other bodies such as Chief Controller of Explosives. Their requirement is mandatory in India. That's briefly what a pressure vessel looks like and what we do.